Hello, this video is on how the periodic table is organized, and it's going to help you fill in your Unit 3 e-notebook slides 8 through 10. So if you don't have that open yet, please get that opened up. You can pause the video and open that up. So looking at how the periodic table is organized, we have, 118 different elements that we know of, and we've organized these into groups or columns and periods, which are the rows. And in this video, you are going to learn kind of how and why it is organized in this way. Okay, so in order to understand how the periodic table is organized, it is important to understand electrons. So if we recall, there's three types of subatomic particles, or particles that you can find within an atom. Those are protons, neutrons, and electrons. The protons and neutrons are located inside the nucleus, a very dense, very tiny area in the center of an atom. Okay, it doesn't take up a lot of space. The electrons, however, are what fill the atom. Okay, so most of the volume of the atom is taken up by these electrons whizzing around. Okay, and actually most of the atom is empty space. But these electrons have kind of a large area around that nucleus where relatively large area around that nucleus where they're kind of flying around. And electrons have a negative charge, and we can say that they orbit the nucleus, although we're kind of simplifying things because we actually don't know the exact location of electrons. They're very tiny, and there's uncertainty that is involved, and probabilities when you get into more advanced chemistry. You actually can't pinpoint the exact location of an electron. You actually have to talk about the probability of an electron being in a certain location. Okay, so anyway, that's kind of beside the point. We are going to model where electrons are in atoms, and that will help us understand how the periodic table is organized. Okay, so understanding where electrons are in an atom helps us understand why a certain element is located at a particular spot on the periodic table. Okay, so we are going to spend some time talking about the Bohr model of how to model where electrons are found. And again, we are simplifying things, and a lot of times in science it makes things easier to understand, and it actually helps us think about complex things by modeling it as a kind of a simplified version of what's going on. Okay, so we can think of electrons as being found in shells around the nucleus. Okay, so like a three-dimensional sphere or shell around the nucleus. There are different shells with different radii from the nucleus. So okay, if this is easiest to learn by kind of looking at examples. So if we looked at aluminum has 13 electrons. Okay, the inner shell of the shell that's closest to that nucleus can hold a max of 2 electrons. And that's not just true for aluminum, that's true for any type of atom or any element. Okay, so the first electron shell holds 2 electrons. Okay, the second electron shell can hold a maximum of 8 electrons. So when we're looking at aluminum has 13 electrons. The first 2 electrons that you place, electrons want to be close to the nucleus. The nucleus is positively charged, those electrons are negatively charged. The lowest energy spot available for them is that first shell. So those first 2 electrons go into that first shell. The next 8 can fill into the second shell of electrons. Okay, so now we have a spot for 10 electrons, but aluminum has 13, so there's 3 more electrons that need to go somewhere else. And there's a third shell of electrons. In this class, the third shell will never have more than 8 electrons, but technically the third shell or third energy level can hold a maximum of up to 18 electrons. Okay, again, in this class, we're going to look at just elements 1 through 20. So the most electrons that something will have in that third shell would be 8. Okay. These models where you draw a circle around the nucleus to show the different electron shells, and then you put dots to show where the electrons are, these are called the Bohr models. Okay, the Bohr model of of electrons, okay? Sometimes you might refer to them as an electron shell diagram, or you might hear me refer to them as an electron shell diagram. But these show all of the electrons that an atom has, and they show the location in their energy level or their electron shell, okay? And again, remember that first shell can hold up to 2, okay? The second shell holds up to 8, and the third shell holds up to 18, but in this class, it will have only up to 8, okay? And there's a little nuance there. Technically, we're looking at just S and P orbitals and the bonding electrons. So really, we are only going to show up to 8 electrons in that third energy level, okay? So these spots are important. You'll notice that I've kind of paired these electrons up. Let's take a look at the second shell. Okay, that's a full electron shell, and they all have partners. Okay, so I draw 2 electrons here at the top, 2 electrons on the right side, 2 electrons at the bottom, and 2 electrons on the left side. Okay, but when we get to the third shell, I only show 3 electrons, and none of them are paired up. When you draw these Bohr models, okay, you want to put 1 electron on the top, okay, 1 on each side, and then 1 on the bottom, and then only when you have 1 on each of those spots, then you come back and you start pairing the electrons up, okay, until you have up to 8, okay? So these outermost electrons, these ones in the outermost shell, I have kind of highlighted blue. These have a special name. They're called valence electrons, and they're the electrons in that outermost energy level, and they're kind of the most important one, you guys. Those are the electrons that are involved in chemical reactions. Okay, so we are going to look specifically at valence electrons a lot in this class, and we'll actually show a different model of how to model an atom, and we call those a Lewis structure. And those are kind of even simpler than these Bohr models. They don't show all of the electrons, they just show the valence electrons. Because valence electrons are so important, we have a special model of an atom that just shows the valence electrons. Okay? So that is a Bohr model, and that's what, if you see a model of an atom like this, with circles and dots, this is called a Bohr model and is showing the location of electrons around the nucleus. And again, this is definitely not to scale. And again, electrons really don't orbit the nucleus like a planet would orbit the sun. But this gives us a simplified model, and we can talk about the location of electrons, okay? And this helps us understand bonding and how atoms combine together. So it's a useful model, okay? Even though it's not necessarily exactly how electrons behave in reality, okay? Now, let's connect this to how the periodic table is organized. Now that we know about where electrons are located, we can actually look at the periodic table and figure out some of that organization of the periodic table and why elements are organized into columns the way they are, okay? And columns and rows, right? So our periods are our rows of the periodic table. If we look at this very first row, okay, and again, if we look at this first row, we only have 2 elements in the first row of the periodic table, okay? But those elements just have 1 electron shell. If you were to draw the Bohr diagram for an atom in the first row of the periodic table, or an element in the first row of the periodic table, just going to have 1 shell, okay? Anything in that second row, okay, and again, there's blank spots, kind of everything in the second row here, including the stuff over here on the right. Those are all in the second row, even though there's a gap. All those elements have 2 electron shells. Okay, everything in the third row is going to have 3 electron shells, and so on. Everything in the fourth row is going to have 4 electron shells. Okay, sometimes you'll hear these called energy levels. Okay, and so on as you move down the periodic table. So in your notes, you want to fill in that the row number or period number equals the number of shells or energy levels of electrons that the element has. Okay, so go ahead and pause the video real quick and you can fill that into your notes. Okay, and then if we look at the column number, the ones place of the column number will tell you how many electrons that atoms of the element have in their outermost shell, okay, or how many valence electrons that atoms of that element in that row or in that column have. Okay, so if we look at the first column of the periodic table, all elements in that first column will have one valence electron in their outermost shell. Okay, so like in the second row here, the valence electrons are going to be in the second shell, and it will only have one electron in that second shell. If we look at the fourth row here, okay, this element right here would have one electron in the fourth shell, okay, or the fourth energy level. Okay, anything in column 2 is going to have 2 valence electrons. And notice that helium is kind of an exception here. Helium also has 2 valence electrons. Remember that first shell can just hold 2 valence electrons. So helium is kind of a funny element in its location on the periodic table. It has a full energy level because that first energy level only holds 2 electrons. But it's located over here because it has a full energy level, but it really only has 2 valence electrons. So it's similar to the elements in the second column in that it only has 2 valence electrons in its outermost shell. Okay, looking over here at the column 13 on your periodic table, again, we just look at the ones place. Column 13 will have 3 valence electrons. Oops. Column 14, okay, we just look at the ones place. Column 14 will have 4 valence electrons. Column 15, anything in that column will have 5 valence electrons, or 5 electrons in its outermost shell. Okay. Anything in column 16 will have 6 valence electrons in its outermost shell. Anything in column 17 will have 7 valence electrons in its outermost shell. And everything except helium in that 18th column will have 8 valence electrons in its outermost shell. Okay, so hopefully you're kind of understanding the trend here. Looking at column number, the ones place of the column number, that tells you how many valence electrons are in the outermost shell of an element in that column. Okay, elements in the same column have similar properties because valence electrons are the ones involved in chemical reactions. So if you look at column 17 here, the halogens, okay, those are going to be very reactive because they really they really want one more. So we haven't gone into this yet, but having 8 valence electrons, that's like the ultimate goal of an atom. It really likes to have 8 valence electrons. So column 17 halogen elements here really want one more valence electron so they can have 8. So they're extremely reactive and they will like steal electrons from other atoms and go around and be very reactive. Okay, because they just are missing 1 valence electron because they only have 7 and they really want 8. Okay, so anyway, those are the rules, and we're actually going to do a couple examples here. So let me go ahead and get up the examples, and we'll go through and kind of look at how the periodic table can help us draw a Bohr model of an atom. Okay, so here we have some examples. So the first example I want to do for you is let's draw the Bohr model of magnesium. Okay, so magnesium is located right here on the periodic table. Okay, oops. So it is atomic number 12. Okay, that means it has 12 electrons. So the atomic number is 12. So it has 12 electrons. Also has 12 protons. But right now, our Bohr models, we care about electrons. So we know that it has 12 electrons when it's uncharged. We also know that it is in column 2. Okay, this tells us right here, column 2. Okay, or the 2A is helpful as well. So column number 2. And remember, the column number tells us how many valence electrons. So it has 2 valence electrons. Okay, and this E with a minus sign is my shorthand for electrons. Okay, and then we also know it is in row number 3 or period number 3. Okay, so that means it has 3 shells. Okay, so let's go ahead and draw this out. So I have Mg, here's my nucleus, kind of colored in. Here's my nucleus with my protons and neutrons. And then I have 1, 2, 3 shells. Okay, so my 3 shells, my first shell always has 2 electrons. So I'm going to draw those 2 paired up right there. My second shell, well, I know I have 3 shells. So my second shell, if I have 3 shells, my second shell is definitely full. Okay, so I'm going to have 1, 2, 3, 4. After I draw 4, then they come back in pair. 5, oops, that one got a little weird. 6, 7, 8. Okay, so there's I have a total of 10 now. So I still have 2 more. And I know in that outermost shell, the third shell, I'm going to have 2 valence electrons. So I have 1 here and 1 here. And then if I count, okay, I have 12 total electrons. 2 plus 8 is 10, 11, 12 in my outer shell. Okay, so that's good. I have 2 valence electrons. I have 2 electrons in my outermost shell, so that's good. And I have 3 shells. So I've kind of accomplished everything, and that would be the Bohr model for magnesium. Okay, so now my second one is I'm going to draw for sulfur. Okay, so sulfur here is number 16, right? Okay, so sulfur is atomic number 16. Okay, so that means it has 16 electrons total. Okay, if I look at the column number, okay, it's in column 16. Okay, so this just happens to be column 16 as well as atomic number 16. So column 16, that means I just look at that ones place. So I have 6 valence electrons. That means I'll have 6 electrons in that outermost shell. Okay, and then I'm in row 3 again. Sulfur again is in row 3. Okay, so row 3 equals 3 shells. Okay, so here let's draw my sulfur, and my atomic symbol is S, or my chemical symbol is an S. So I'm going to draw an S in my nucleus, and then I kind of shade it in. Okay, and then I have 1, 2, 3 shells, and that got kind of messy, didn't it? But I have 2 in that first shell, and then I have 1, 2, 3, 4, 5, 6, 7, 8 in my second shell for a total of 10. And then I still have 6 more electrons I need to place. So 1, 2, 3, 4, 5, and 6. Okay, and then I double check. I have a total, if I count, of 16 electrons. Okay, I have 6 valence electrons. If I count the ones in the outermost shell, I have 6 total. And I have 2 that are paired up and 2 that are by themselves. That's important, okay? 2 of them are paired and 2 of them are by themselves, because I fill 4 first that are unpaired, and then they come back and they get a partner, okay? And then I have 3 shells. So I've actually taken care of all 3 of those, and that would be my Bohr model of sulfur. Okay, I have another example for you. If you are following along on maybe a scratch piece of paper, I have a question for you. I want you to draw the Bohr model of carbon. And if you've watched this video, go ahead and bring in your examples, or at least this one. I want you to draw the Bohr model of carbon and bring that to next class, okay? So I can kind of use that to gauge if you watched the video. Okay, so make sure you put your name at the top. If you want to have the 2 examples I went through drawn, you don't have to, but I do want you to draw the Bohr model of carbon for me, okay? And just so we can all find it on the periodic table, carbon is right here. It has atomic number 6, okay? It's in column 14, and it's in row 2, okay? So that one there. Carbon is the one that I want you to do on a separate piece of paper. Put your name at the top, and you're bringing that to next class. Okay, thanks for watching the video, everybody. I hope this was helpful. Remember, this helped you fill in slides 8 through 10. Okay, we answered the question, like, how is the periodic table organized, and how is that related to electrons? And we also learned how to draw Bohr models.